We are looking at notes 3.3, which are on graphs of rational functions of this form, ax plus b over cx plus d. So for each function, fill in the chart. Use the characteristics to sketch the graph of the function. Describe where the function is increasing or decreasing. So we're going to identify each one of these characteristics. We're going to graph it. And then we're going to figure out where is our function increasing or decreasing, okay? So first of all, how is this in the form f of x equals ax plus b over cx plus d? So over here, I can say that my a value is 0, the b value is 2, because in my numerator it's just 2. Then the c value is 1, and the d value is just -3, okay? So the first thing I want to do is find the domain. Well, if I look at my equation right here, it's clear that x can be any value except for 3. So therefore, I can say my domain is x is an element of the reals, but x can't equal 3. Okay, so now the next thing I need to do is find my intercept. So I want to figure out my y-intercept. Well, my y-intercept will happen when x is 0. So I'm going to find f of 0. So I'm going to do 2 over 0 minus 3. So I get 2 over -3, okay? So therefore, my y-intercept is going to be 0, -2/3. Now, for my x-intercept, I have to actually plug 0 in for f of x. So I'm going to say 0 equals 2 over x minus 3. Now remember, we said that we can multiply both sides by x minus 3 to cancel it out. So I end up getting 0 equals 2, which is impossible, which means I don't have any x-intercepts. That should make sense to you because f of x will never equal 0 because we have an asymptote there. So I only have one y-intercept and no x-intercept. Okay, so now I need to find my asymptotes. So I know my vertical asymptote will have to occur when x is equal to 3, because I know I don't have a hole here because nothing cancels out. So I know for a fact that I have a vertical asymptote when x equals 3. Okay, but what about my horizontal asymptote? So this one right here is vertical. What about my horizontal asymptote? Well, remember we learned in the last lesson that if the degree of the numerator is less than the degree of the denominator, then we will always have y equals 0 as our horizontal asymptote. So we know that our horizontal asymptote is going to be y equals 0. Okay, now lastly, I want to figure out where I have positive and negative intervals. So in order to do this, what I'm going to do is I'm going to create a number line with my critical points. And essentially, my critical points are just in my graph where I have asymptotes and x-intercepts. Since I only have one asymptote and no x-intercept, I know that 3 is my only critical point. So I'm going to test some values here. Also, by looking at my graph right here, my equation right here, I can see that the only breaking point that I have is when x is 3 as well. Okay, so now that I've done that, I'm going to figure out, well, what kind of a value will I have before and what kind of a value will I have after? Well, if x is less than 3, so let's just go ahead and test 1. If I plug 1 in, it would be 2 over 1 minus 3, so I get 2 over -2, which is -1. So I get a negative value anywhere to the left of 3. Okay, now I want to do a value to the right of 3. So I'm going to figure out f of 4. Any value I want, I just randomly chose 4. So I'm going to say 2 over 4 minus 3. So I get 2 over 1, which is 2, so it's positive. So I know that my graph is going to be positive everywhere from 3 to infinity, and I'm not going to include 3 because it's undefined at 3, and I know that it's going to be negative everywhere from -infinity to 3 because that's what we figured out right here. Okay, so now that I've done that, I can go ahead and start graphing some information out. So I need to do a proper scale on my axes. So I'm going to put 0 here, and I think going up by 1s on my x-axis might be a good idea. So I'm going to just skip to 5 and then 10 and then I've got -10, and I've got -5, okay? And since my y-intercept is at -2/3 right here, I think I'm going to go by thirds for my y-axis. So I'm going to say every 3 blocks is a whole number. All right. So this is what my graph will look like right here. Now I know for a fact that I have a vertical asymptote at x equals 3. So I'm going to graph out my vertical asymptote right here, and I'm good to go for my vertical asymptote. I also know that I have a horizontal asymptote at y equals 0. So I know I have a horizontal asymptote right here. Those asymptotes are going to be extremely important, okay? Now, in order for me to be able to do some true graphing out right here, I have one more thing I have to do. And one more thing I have to do right here, first of all, before I do that last thing, it tells me that my graph is going to be positive from 3 to infinity. So therefore my graph, let me get my highlighter out, my graph is going to be positive in this section right here. And then I also know it's going to be negative from infinity to 3. So up until my asymptote right here, I know my graph over here is going to be negative. So I know that I'm going to have graph here and graph here. Okay, so now my question is, how is this going to look? So I want to see what the behavior is going to be like really close to 3. So I'm going to start plugging in some values very close to 3 to see what ends up happening. Okay, so essentially what I want to do is figure out what f of maybe 2.9 is going to be, see what kind of an answer I get. So I'm going to go ahead and do this. Sorry, let me minimize that. So I'm going to figure out 2.9. I'm going to store it in as x. And again, if you want to do this on Desmos, you can. And then I'm going to figure out what 2 over x minus 3 is, and I get -20. So I know that this is approaching on the left side of my graph. It's going down towards -20. Well, I want to get even closer to 3. So let's go ahead and do that. So I'm going to take 2.99, I'm going to store that in as x, and I'm going to do the same thing, and it's an even larger negative, so it's very clear that this is going down. It's approaching -infinity over here, okay? So now let's see what's happening on the other side. So I want to know on the right side, right here, of my asymptote. So I'm going to go slightly to the right, so I'm going to figure out f of 3.1. So I'm going to take 3.1, I'm going to store it in as x, and I end up getting 20. So this right here is 20. I'm going to get even closer to 3, so I'm going to try 3.01. Okay, and when I do that right here, I end up getting 200. So it's even larger. It's approaching infinity in the positive direction. Based on all that information, I can figure out right here that my graph will look something along these lines. Oh, and I forgot to put my y-intercept. So my y-intercept right here is -2/3. So right here, it's going to be approaching -infinity along the asymptote of x equals 3, and it's going to be approaching 0 along my horizontal asymptote of y equals 0. Okay, here it's going to be approaching positive infinity from the right side, so my graph will end up looking like this. Okay, the last part of the question asks me to describe where the graph is increasing or decreasing. So if I were to look at my graph right here, I can see, sorry, let me just move this. I can see that the graph is constantly decreasing on my whole entire domain. The only issue is I can't say that it's decreasing from -infinity to positive infinity because it doesn't have a value at 3. So right here, it doesn't have a value at 3. So I can say that it's decreasing from -infinity to 3. Nothing's happening at 3 because we don't have an actual value at 3. And then it's also decreasing from 3 to infinity. Where is it increasing? Nowhere. My graph looking from left to right is not increasing at all. So therefore, this is going to be my answer right here. Okay? All right, so now I just want to confirm that everything I did here is correct. So I'm going to type in my function. So I got f of x equals 2 over x minus 3. We said that we should have an asymptote when x is 3 and when y is 0. So let's go ahead and graph out those asymptotes. So x equals 3, definitely have an asymptote there. And then when y equals 0, we definitely have an asymptote there as well. Great. We also have an x-intercept of 0, -2/3, okay, which is exactly what we expect to have here, okay? And then as we're getting closer to our asymptote from the left side, it's approaching -infinity. And as we're getting closer to the asymptote from the right side, it's approaching positive infinity, and our graph is constantly decreasing everywhere except at -3. So we verified our solution for number 1, okay? Okay, number 2, f of x equals x minus 2 over 3x plus 4. So the first thing I'm going to do is find my domain. And my domain, my restriction, is going to be when my denominator is equal to 0. So I'm going to set the denominator equal to 0, subtract the 4, so I get 3x equals -4, which means x can't be -4/3. So therefore my domain is all reals except for -4/3. Because this didn't simplify for me at all, there's no common factors in my function right here, I can go straight to saying that I have a vertical asymptote at x equals -4/3. So we'll say this is a vertical one at x equals -4/3. Okay, so now we want to find our x-intercepts. So to find our x and y-intercepts, excuse me, let's find our y-intercept first, because that's nice and easy. We're going to figure out what f of 0 is. So to do that, I'm going to just plug 0 in every time I see an x. So I get -2 over 4, so I get -1/2. Therefore, my y-intercept is going to be 0, -1/2. So I can say that I have a y-intercept here. Now for my x-intercept, remember we have to plug in 0 for f of x. So I'm going to say 0 equals x minus 2 over 3x plus 4. And since it's an equation, I can multiply by 3x plus 4 on both sides. So what does this turn into? Well, 0 times 3x plus 4 is just 0, and then my 3x plus 4's on this side cancel out. So therefore, I get x equals 2. So I have an x-intercept at 2, 0. Okay? So now that I've done that, all that stuff, the next thing that I want to do is figure out where my graph is going to be positive and where it's going to be negative. Well, my critical points are occurring, again, on my x-axis. Where are my critical points going to be? Well, I know that I have a critical point at my vertical asymptote as well as at my x-intercept. So when I do my number line right here, I'm going to put -4/3, and then I'm also going to put 2, okay? And I'm just going to go ahead and test some values. So I'm going to test a value to the left of -4/3. So I'm thinking I can test, I don't know, let's try -10 and see what we end up getting. So I'm going to take -10. I'm going to store it in, sorry, -10. I'm going to store it in as x, and I'm going to type in my equation, or my expression. So my expression is x minus 2 over 3x plus 4. So I end up getting 6/13, which is a positive value. So I can say right here that it's positive along this interval. Then I'm going to try a value in between. So I'm going to try 0. So if I take 0 and I store that in as x, do this piece right here, I get -1/2. So this right here would be a negative value. To the right over here, I'm going to try 5, just randomly choosing a value. So 5, I'm going to store it in as x. Go ahead and figure out your value. You get a positive 3/19. So I know that my graph is going to be positive from -infinity all the way to -4/3, as well as from 2 to infinity, okay? And I know my graph is going to be, so this is going to be my positive interval. And we conclude that it is going to be negative from -4/3 until 2. So how do I graph this out? Well, again, I want to figure out a proper scale to put in my x and y axes. I know my x-intercepts are -1, or sorry, my y-intercept is at -1/2 and my x-intercept is at 2, but I also have a vertical asymptote at -4/3. So I think for my x-axis, I'm going to place a whole number every 3 blocks right here. So -3, -2, -1. And I think for my y-axis, I'm going to place a whole number every 2 blocks. So I'm going to say 4, 3, 2, 1 here. And I'll say -4, -3, -2, -1. Okay, so now that I've done that, I can go ahead and start graphing out some information. Well, I know my y-intercept is at -1/2, so I'll put a point there. And I also know that I have an x-intercept at 2. Okay. We also know that we have a vertical asymptote when x is -4/3. So what I'm going to do is I'm going to go to -4/3 or -1 1/3, and I'm going to draw in my vertical asymptote right here. Okay, and I totally forgot to do the horizontal asymptote, which is probably the newest thing that we have in this problem right here. So I just want to make sure you guys are okay with finding the horizontal asymptote. So to find my horizontal asymptote, I have to look at my function and see right here. If the degree of the numerator and the denominator are the same, it's not going to be 0. Okay? So since it's not going to be 0, then what's it going to be? How do I figure this out? So if I know f of x is equal to x minus 2 over 3x plus 4, when we're figuring out our horizontal asymptotes, we're looking at large values of x. So when x is like approaching infinity, basically. So when x is approaching infinity, if I put infinity in here and I subtract 2, I still will be at infinity. And if I take 3 times infinity and I add 4 to it, I'm still going to be at infinity. So this -2 and this +4 really don't make a difference. So to find my horizontal asymptote, I don't care about this -2 or this 4. It's negligible. So it's x over 3x, which simplifies to 1/3. So that means that I know that I'll have a horizontal asymptote when y is equal to 1/3. So I'm going to go ahead and graph that out right here. So when y is 1/3, my graph will be approximately in this area right here. Okay. So once I've done that, I have some information to help me figure this out. Now, I need to figure out right here what happens when I get close to -4/3 on the left side and what happens when I get close to -4/3 on the right side. So if I know I have -4/3, -4/3 is -1.33333. So what I'm going to do on the left side is I'm going to store in -1.34. And I'm going to store it in as x, and then I'm going to type in my equation, which is my expression, which is x minus 2 over 3x plus 4. And I get positive 167. So I can say right here that f of, sorry, let me just get my pen. F of -1.34 is 167. So I know that my graph is going to be moving upward right here. Okay, now I'm going to do it on the right side of this value. So I'm going to try -1.32. So -1.32, I'm going to store it in as x. And when I figure out my value, I get -83. So it's going to be approaching negative infinity on this side. Let me grab my highlighter and we'll use our positive and our negative intervals to figure this out right here. So we know it's going to be positive everywhere from -infinity to -4/3. So it's going to be positive in this area right here. We know it's going to be negative until we get to 2. So it's going to be negative in this area, but then over here it's going to be positive. Okay? So once I've done that, I've also figured out that my graph is going to be going up over here, and then it's going to be going to negative infinity over here. So it's technically going up because it's increasing from negative infinity from here. So now that I figured all that information out, I can draw my sketch. I know that this graph right here is going to be increasing as follows here. And I know my graph is going to be increasing here. It's going to go through this y-intercept at -1/2. My x-intercept at 2, and it's going to try to approach this asymptote, but it just won't touch it, and that's what my graph will look like right here. So the last piece asks me to figure out where is my graph increasing and where is my graph decreasing. Well, it's increasing everywhere except at -4/3, and it's not decreasing anywhere at all. So I can say it's increasing from negative infinity to -4/3, as well as from -4/3 to infinity. Where is my graph decreasing? It's not at all. Okay? All right, let's verify to make sure that everything we did here was correct. So if you take a look right here, we have f of x is equal to, let's see, I have in front of me, x minus 2 over 3x plus 4. And we said that we think that we should have a vertical asymptote at x equals -4/3. Which, again, we've shown on Desmos that this is true. We definitely have an x-intercept there. Sorry, a vertical asymptote right there. And we also should see that we have a horizontal asymptote at y equals 1/3, which this does verify for us that we get 1/3. Now, let's find our x-intercept. We should get x equals 2 right here. And then our y-intercept is at 0, -1/2. So everything that we figured out does check out. And then we also know that our graph is going to be increasing everywhere except at -4/3. Okay, we're going to take a look at question number 3 together, and then we should be good to go for this topic. All right, have a good day.